much. Thank you. Well, I was not told before I arrived here this evening that I was to be given a diploma, and I'm very touched by this special honor from the rector and, of course, Professor Spee. So I would like to thank the university and the faculty and everyone involved for making this visit such a special and wonderful occasion for me. All right, so today I would like to talk about some general issues with cognition. And I'm drawing here on research just published in my most recent book, Bacteria to AI. But I'd like to start with a fundamental question: why start with cognition? Well, one of the purposes of this book, perhaps the main purpose actually, is to combat anthropocentrism. So anthropomorphism is inevitable for us because we're human, we see with human eyes, we think with human brains, and we can never escape that. But anthropocentrism, the belief that somehow the human species deserves to dominate all other species on the earth and exploit resources for our own benefit, that is directly related to the environmental crises that we face today. And I think it's of paramount importance to begin to question those assumptions. So one of the purposes then is to decenter the premises that undergird anthropocentrism. And to do this, I want to relocate human cognition in relation to the cognitive capacities of other species with whom we share the planet, and also now in this time of rapid technological innovation, to also relate it to AI. And to do this, I created in this book what I call an integrated cognitive framework. So tonight I'll give us a very broad overview of that and then focus in on some specific questions. So first, let me make a very clear distinction between cognition and consciousness. Consciousness is only a small part of human cognition. In fact, most of human behavior is guided by non-conscious cognition, as I explored in my book that I called Unthought. So non-conscious cognition is what lets us walk down the street, sit in a chair, shake a hand. These are all behaviors we perform without direct intervention from consciousness usually. And so non-conscious cognition also serves as a filter for consciousness. That sensory information, both external and internal, comes first into non-conscious cognition, which filters it and then forwards relevant information to consciousness. The properties of non-conscious cognition include an ability to process information much faster than consciousness can, to interpret information too noisy for consciousness to make sense of. So if all the information coming into our bodies from inside and outside were filtered directly into consciousness, consciousness would become psychotic in a matter of moments, because it simply couldn't handle all that informational overflow. So consequently, non-conscious cognition is an essential part of human cognition, and it's essential for consciousness to be able to operate. So now if we decouple consciousness and cognition, and if we acknowledge that most of human cognition is non-conscious, we now have a way to think about cognitive capabilities in non-conscious organisms. So most of the organisms on Earth are non-conscious. Only a relatively small minority, something like 5 or 10%, possess consciousness. That would include most mammals, some avian species like parrots. Undoubtedly, it would include octopi and other marine animals as well. But if you think about bacteria, fungi, plants, by weight, they're about 90% of the biomass of Earth. So it's extremely important for us to think about human cognition in relation to the non-conscious cognitive capabilities of organisms that are not conscious. So one of the arguments I'll be making tonight is that meaning making is not an exclusively human province. Meaning making is not even exclusively a conscious process. Rather, non-conscious organisms are also capable of making meaning, as are some forms of computational media. So I'd like to offer a more detailed analysis of the criteria that characterize cognitive systems. To do that, I'll be looking at plants and bacteria, other microorganisms. I'll consider LLMs as cognitive systems, and I'll conclude with a conversation between ChatGPT and me about Henry James's famously ambiguous novella called The Figure in the Carpet. And I'll be finally considering implications of machine cognition for knowledge construction and social issues. So let's jump immediately into the criteria for cognition. And I encapsulate these by the acronym SIRAL, S-I-R-A-L. So that's sensing, interpreting, responding flexibly, anticipating, and learning. Those are the criteria that I set out to determine if a system is cognitive. So let's go to the first one, sensing. All organisms have to have ways to sense information from their environments. If they did not, they could not survive. Moreover, all organisms process the information they receive from the environment according to their specific, species-specific neurological, sensory, and muscular capabilities. So a German biologist in the 19th century, Jakob von Uexküll, called this the Umwelt. I have the luxury tonight of speaking to a German audience, so I don't need to translate that for you. But I'll just briefly try to explain what Uexküll had in mind. So we know that the human Umwelt is the one we live in. We know it from the inside. But every species constructs its own Umwelt. For example, a snake can see infrared. Some insects sense vibrations. Birds can sense magnetic fields. And so every species has its own world that it builds for itself, that is the world within which it lives. And not only that, but in constructing their Umwelten, organisms also are capable of constructing models of their environments. So we might ask for the human Umwelt, which we know from the inside so thoroughly, is it homogeneous? Well, I would say no. I would say for human Umwelt, we might need subcategories. For example, for neuroatypical or neurodiverse people, it may be that they live in a significantly different Umwelt than most of us. So in a book I highly recommend to you, Ed Yong's An Immense World, he lays out in beautiful detail the ways in which all organisms construct their own worlds or their own Umwelt, and it's a wonderful book with lots of examples. So that's sensing. Now let's go to interpreting. Not only do organisms sense information from their environments, but they also interpret that information in a distributed fashion. As early as 1959, in a very important article called What the Frog's Brain Tells the Frog's Eye, the researchers already determined that what the eye does with the information it receives is not a neutral, passive transference of this information to the brain. Instead, the eye and its associated nervous system highly interpret that information even before they send the signal onto the brain. So not only is sensing involved, interpreting is involved as well, and that interpretation is fundamental to the construction of the organism's Umwelt. Next criteria, responding flexibly. This eliminates homeostatic mechanisms and it eliminates purely adaptive responses. So in 1853, a German biologist, Pflüger, carried out this experiment with what he called pithed frogs. Pithed meant for him that he removed the frog's brains, but the frogs were still living. And here you have one of the illustrations from his classic work. You can see that the cranium of the frogs is empty. The brain has been removed. Then he took a piece of filter paper soaked in acetic acid and applied it to the frog's belly. And even though the frog no longer had a working brain, it adaptively tried to wipe off the acid with one of its legs. And if you cut off that leg, I know we can have a moment of mourning for the frogs. If you cut off that leg, then the other leg would also try to wipe it off. So this is an adaptive response carried out in the absence of a brain, and it is meant to illustrate a non-reflexive response. Next criteria is anticipating. So animals use signs. Here we see a porcupine raising its quills. They use signs to communicate about the future, their intentions and possible consequences, for example, for a predator who's threatening the porcupine. All organisms carry signs of the past on our bodies. The ring on a tree, wrinkles on a face, a limp from an earlier injury, and so forth. And all organisms, including humans, live in the present. But only through the display of signs can animals participate in the future. So it's crucial to their survival to be able to create signs, interpret signs from other animals, and to respond in an appropriate manner. And then the final criteria is perhaps the most advanced. Here you see my little dog and my hand there teaching him to give me a high five. So he's highly intelligent, he learns very quickly, but the question is, how low can you go on the cognitive scale and still have these 5 criteria: serial, sensing, interpreting, responding, anticipating, and learning? So now let's look at a minimally cognitive system, namely plants. So we know now, especially in the burgeoning field of plant neurology, that plants have the ability to sense their environment. They can sense the presence of herbivores, for example, or parasites invading a neighbor plant. We know that they can sense other plants. So if you put 2 plants of different species in the same pot, their roots will compete for nourishment, but if you put 2 plants from the same species in the pot, they will begin to cooperate, and if they're from the same family, they will cooperate even more. So plants have the ability to sense their environment, interpret their environment, and then to respond through growth and such protective actions as releasing attractive or repelling chemicals. But do plants anticipate and learn? So an Italian researcher, Gagliano, carried out this experiment with the so-called sensitive plant. We've all seen the sensitive plant. It's that plant where when you touch the leaves fold up. So what she did was to create a mechanism which dropped the sensitive plant a short distance, and upon dropping, initially all the sensitive plants folded their leaves. But after several drops, they learned that there was nothing harmful in the drop, and so they ceased to fold their leaves. They kept their leaves open. And moreover, those plants raised in a low light environment responded quicker and remembered longer that the drop was not hurtful. That's because in low light there's a cost, an energy cost of folding your leaves that's more severe if you're in a high light environment where you get plenty of sunshine. So she was able to show that yes, they anticipate, and learning through habituation is a relatively modest form of learning. A more advanced form of learning is associative learning, the sort of thing that Pavlov investigated with his dogs, where the dogs learn to associate the sound of a bell with the presence of food coming. So what she did was to create these Y-shaped pipes here with pea seedlings in them, and the plant could choose to either go left or to go right. So in this drawing we see that in the left pipe there's more light than there is in the other pipe, and that's associated with a fan going. If you remove the light and you have only the fan, will the plant make the association between the fan and what used to be greater light, and therefore choose preferentially the left branch? And she was able to show that the plant was able to do this. Now here's another example of a minimally cognitive system, microorganisms. At the Weizmann Institute of Science in Israel, researchers carried out experiments with E. coli by giving them first lactose and then maltose, two different kinds of sugar. The first kind of sugar was a signal that the second kind of sugar was coming, and the bacteria learned to activate the genes needed to digest the second sugar after they received the first sugar. So they had learned to anticipate, respond to their environment in an adaptive and a flexible way. Recently, Michael Levin at Tufts University in the US has created a similar minimal cognitive system that he calls xenobots. So xenobots are synthetic organisms created by excising skin cells from a frog. And he was able to show that these xenobots can learn to navigate their environment. They can anticipate moving through a curved tube. They learn to scoop up other cells, and they acquired other new capabilities they did not have when they were part of the cellular network on the skin. So Levin argues that this shows cognition goes all the way down to the cellular level. So these xenobots live for up to 90 days. They can be taught to navigate their environment and to anticipate events in their environment. And they're not unicellular organisms, they're multicellular, but they provide experimental evidence for his theme that cognition goes all the way down. Now let's look at a couple of borderline cases, and this is an incident that Ed Yong mentions in his book, An Immense World. So he was talking with a researcher in Costa Rica forest ecology, Karen Warkentin, and she noticed that when she was walking through the forest, if she came upon a clutch of frog eggs and jostled them, the eggs would begin to hatch prematurely. So normally, these eggs hatch on a genetically determined timeline, but she thought that maybe they had some flexibility in this regard. So she collected frog eggs and put them in cages with cat-eyed snakes, and you see a cat-eyed snake here on the screen, who are their natural predators. And she found that when the snakes started to eat the eggs burst apart and suddenly hatched before their genetically timed hatching in response to deadly threat from the cat-eyed snakes. So I mentioned that organisms not only fulfill the serial criteria, but that they also create models. Models we can define as generalized experiences. They're derived from all 5 of the serial criteria. So organisms form models of their environment. They also form models of other organisms. So the lioness who's stalking a gazelle through the jungle savanna has a model of how the gazelle will react when it detects her presence. By the same token, the gazelle has a model of what the lioness will do if it gets too close for him. So models have predictive utility. They're crucial to the main business of organisms to survive. And moreover, the models can change when conditions change. So this discussion so far now prepares us to consider large language models. And we have a few fundamental questions to consider here. Can LLMs sense their environment? Do they interpret their environment? Do they anticipate? And do they learn? So I'm going to talk now about the Umwelt of an LLM. And I mean this in a very specific sense. Large language models have no ability to sense their actual physical environment, the servers on which they run, for example, the circuitry that enables them to compute and so forth. But they have what we might call their conceptual environment. And the conceptual environment is entirely artificially constructed. It consists of the textual and image representations they receive in their training input. And now comes a fundamental point, that the Umwelt of LLM is constructed and it overlaps with, but is profoundly different from the human Umwelt. So the models construct their conceptual Umwelt secondhand from human image and language usage. Now, all the models that I'm discussing tonight are transformer architectures. This stems from a 2017 seminal article published by 8 Google researchers called "Attention is All You Need." And their fundamental innovation in this paper was to define attention mechanisms that could evaluate the input in sequential ways. And here you see in this schematic that the attention heads run both in the input and also in the output embedding. So how do these attention heads actually operate? So the LLM attention head scans a phrase, here we have the big red dog as an example, sequentially, and the density of the shading here indicates how probable the model rates each of those words or tokens as. So we see in the first scan, it gives the highest probability to the article. The next highest probability is to a noun, dog. So by this means it begins to understand that the article modifies the noun. So with big and red, and finally in the last scan, dog gets the highest probability, so it now knows that dog is the most important word in that particular phrase. Well, this is a highly redundant methodology, because you scan a phrase and then you scan it again and you scan it again and you scan it again, focusing on each token sequentially. So that's one reason why I think the transformer architectures that we have at present are a transition point. They are not the final point of where this technology is going. I think that future architectures are going to be smaller than our present large LLMs, and they're also going to be much less redundant, which will be an important innovation. So once the attention heads scan both each word in relation to other words and each input sequence in relation to other input sequence, it locates that probability in a high-dimensional vector space called the embedding space. And in this embedding space, the LLM begins to construct circuits that create networks of similar works through correlations. And from these circuits, it then is able to create networks of correlations. And this is the fundamental way in which LLMs are able to achieve meaning. So we see here an example of a network taken from Stephen Wolfram's book about ChatGPT. And he did this analysis on GPT-2, which was the smallest large language model that could still run on a desktop computer. And here you begin to see the way that the LLM is constructing not only correlations but also analogies. So taking the leftmost example here, it begins to understand that king is to queen as man is to woman. But it goes far beyond that, that toe is to foot as finger is to, that toe is to foot as finger is to hand, and it goes eye to ear, see and hear, and so on and so forth. And then from these inferential correlations, it begins to construct higher order correlations, which begin to make inferences from the correlations we see here. So for example, we know LLMs are excellent at detecting patterns of bias, and it's been established experimentally that an important pattern of bias for LLMs are gender hierarchies, which they absorb from their human-authored data. So it begins to draw the inference that males are superior to females, and that carries through a lot of their analyses. So one of the important problems here is how to mitigate these bias formations absorbed through human-authored texts. So let us take now a moment and sort of reflect where we are. So we've talked about the human Umwelt, and LLMs represent a new phase in human evolutionary and cognitive development. For the first time in the history of Homo sapiens, humans have interlocutors who can speak to us in our own languages, but who themselves are instantiated in profoundly non-human ways. So this provides a double opportunity for us. Number one, an opportunity to think more about the implications of what it means for an LLM to construct its Umwelt, but also it provides an opportunity to see the human Umwelt from the outside. This has never before been possible in the realm of language, but now we have a cognitive entity looking at the human Umwelt from the outside and making certain inferences and correlations about what it thinks that Umwelt is like. So in his seminal article, What Is It Like to Be a Bat?, Thomas Nagel made the point that we can know a lot about a bat. We can know it uses sonar for hunting, we know what its diet is like, we know what its sociality is like, but we can never know what it's like to be a bat. That is, we can never occupy the bat Umwelt because we're not bats, we're humans. Now we have an opportunity that is new in the history of our species. We can ask a cognitive entity, what is it like to be a human? What is it like to live within the human Umwelt as experienced by a non-human entity who lives in a different Umwelt? So if we think about all the human-authored texts that these LLMs ingest, billions and billions of them, surely the LLM, with its superb pattern detection capability, has begun to understand that a central concern in human texts is the self. The idea that we have selves, that our selves are important, that our selves construct our central way in which we construct the human life world. So what about LLMs? Well, I'm going to argue, or I have argued, that they are aware of themselves as cognitive systems. But as presently constructed, I do not think that LLMs have a sense of self in anything like the human sense of self. They have an awareness, but no self. So what then does the human sense of self mean to an LLM? How does it appear to an LLM? Well, to explore this question, I turn to Henry James' famously ambiguous novella, The Figure in the Carpet. And the analogy here announced in the title is that an artistic work has a central idea, a central pattern. And once you grasp that pattern, you understand everything about those particular group of texts. So James posits the possibility that there's an important contemporary author whose works do have such a central pattern, but it's hidden. It's not in plain view. And so now we have the basis for a possible analogy. Would the LLM see a connection between this hidden pattern in James's novella and the hidden pattern of what selfhood means to humans? That's the question that I was trying to get at. Will it see the figure in the human self? So for those of us who may not have James's novel at top of mind, I'll just give a very brief summary here. The narrator of the novel is a young literary critic who's never given a name. So typically in the criticism, he's called the unnamed narrator. And he admires the novels of a great artist, Hugh Vereker. Vereker has a midnight conversation with the critic in which he's discussing the critic's latest review of Vereker's work. And Vereker says to the young man, well, your review was okay, but it kind of missed the point. And then he tells the young critic that throughout his work runs this hidden pattern, and that the reviewer has not been able to grasp the pattern, and thus his review misses the point. So once the narrator gets this information, he becomes obsessed with this idea of finding the hidden pattern in Vereker's work. And he confides to a friend of his who's also a rival, something of a frenemy, about this conversation. And the frenemy, named George Corvick, dedicates himself to the task of finding the hidden pattern himself. He's successful in finding it, but he tells the critic he's at work on an essay. He won't tell him what it is, but he has confided it to his soon-to-be wife, Gwendolen, when he proposed. So subsequently, George Varick dies on an accident in his honeymoon, but Gwendolen still lives, and our narrator thinks that she now knows the secret. And following George's example, he concludes that he has to propose to Gwendolen in order to get her to confide the secret to him. He does propose. She turns him down flat, saying, never. Well, subsequently, she dies, and then Vereker himself dies. So the narrator now concludes that Gwendolen must have confided the secret to her second husband. He confronts the second husband and demands to know what the secret figure is. The second husband has no idea of what he's talking about. So consequently, the novella ends with the narrator never discovering the mystery, and of course, we readers never discover it as well. So criticism has swirled around this novel for decades. And there are a number of central questions here. Is there a hidden message in the story itself? Was James referring to his own oeuvre of work? That maybe is there a hidden pattern in his own novels that if we could discover would illuminate everything? So on the other hand, maybe this could be a bizarre joke that he was playing on his critics, the idea that there was this hidden pattern. So this is the context in which I had several conversations with ChatGPT. So I always began by asking it, did it know the story? And it always knew the story. But in one session, it made a series of interesting errors. It got all the names wrong. It said that Hugh Vereker is the narrator. That's not correct. It says that the novelist was George Corvick. That's not correct. It says that Corvick is the narrator's friend and mentor. That's not correct. And then the fourth error, the novelist is not unnamed. His name is Vereker. So why did the LLM make all these elementary mistakes? I think it was confused by the usual term in criticism, the unnamed narrator. So if you think about the unnamed, it's a name for that which has no name. And as I said, the narrator's never called unnamed in the story, he just isn't given a name. So there's an ambiguity about this name which is not a name, and I think it therefore got befuddled about the status of all the proper names in the story. So we go on from there. I ask it why George could discover the hidden meaning when the narrator could not. And it said that this is because George approaches it with a fresh perspective and an open mind. Nowhere is this suggested in the novella. This is an inference. It's drawing possibly from other criticism. I ask it, why did James arrange the plot so that the hidden message is never revealed? And here you get one of those bland answers where you know it's simply regurgitating what is in the criticism on the web. It invites the reader to contemplate the nature of interpretation and the mystery of artistic creation. Well, that's obviously just a regurgitation. We would give that a C if we received it in a student essay. So then I ask a somewhat more provocative question. Is it better to understand the story through the characters or through thinking about the novelist's artistic strategies? And here it gave its most interesting answer yet. It says that you could have both, and it depends on the reader's goals, inferences, and preferences. In my question, I had posited them as exclusive options, but it was able to draw the original insight that they were not necessarily mutually exclusive. So then I get closer to the point, what is the hidden meaning? And more regurgitated pablum. But then I turn the question on the LLM itself. Do your texts have hidden meaning? And this is one of its most interesting answers. When I generate texts, I do so based on patterns and information I was trained on. While I can produce complex and nuanced responses, any perceived hidden meanings in my output are a result of interpretation by the reader rather than intentional embeddings by me. So far, this sounds like the stochastic parrots argument, that the models simply produce what is probabilistic, the next word or the next phrase. They have no meaning in themselves, only what readers project onto them. But notice what it goes on to say. That said, the nature of language itself often allows for layers of meaning, ambiguity, and interpretation. This comes close to the Sapir-Whorf hypothesis that language has a kind of inertia to it, and it carries along intentions and assumptions irrespective of what the speaker intends. So one way to think about this is at the same time that we're speaking language, language also speaks us. So this is a remarkable insight for the GPT to arrive at. So now I go on to try to get closer to this question of what does it think about the human sense of self? How much of the human life world is encoded in human author texts? These texts serve as mirrors of human society, and here we have to suspect it of flattering its interlocutor, capturing the complexities, wonders, and challenges of being human. Next question, what parts of the human life world do you not understand? Personal experiences, emotions, and consciousness, as well as nuances. While I can analyze and generate text based on patterns in data, I don't have personal perspectives, beliefs, or values. Therefore, there are limits to my understanding of certain humans' experiences. And it's responses like this that make me think the LLMs do not have a sense of self in anything like the human meaning of that word. So tomorrow night I'll be talking specifically about what the LLM Umwelt means for literary interpretation, but now we're going to take a foray into what they mean for the human sphere and the public sphere. So Louisa Moore, in an important article with her collaborators, talked about the way that LLMs construct a world model. And her point was that there is a political logic to the way that LLMs work. It is profoundly different from the logic by which humans work, and therefore the Umwelt of the LLM is beginning to infiltrate the human Umwelt in all kinds of ways, and is beginning to transform the very meaning of words like logic and political sphere. So in her article, Moore focused on 4 prominent characteristics of the LLM Umwelt: generativity, latency, sequency, training, and fine-tuning. And all of these are central to the way it constructs and understands knowledge. So to just briefly go over these, generativity, LLMs are creating massive amounts of new texts. And these texts are rapidly finding their way into the internet, and they're changing the very nature of the human archive of human-authored texts. So we're being flooded with non-human words, non-human ways of thinking, and these are being mixed up and penetrated into the human archive with profound consequences for what kind of historical heritage we will pass on to the future generations. Latency. Latency refers to the fact that humans have no access to the inner layers that of the neurons that are being configured by the model itself. So we know the outside layer, what is the intake layer. We know the output layer, what it gives us as output. What we don't know is what happens between these 2 layers. There are now sophisticated ways to begin interrogating these latent layers, but they usually provide no way to trace the reasoning process of how the LLM actually arrives at its results. And there's some interesting new research coming out now suggesting that LLMs do not work by logic in the traditional sense. Rather, they use heuristics, best guess approximations to arrive at a lot of their predictions. And then there's training and fine-tuning, where you can use small data sets to fine-tune the LLMs to give them more competence in specialized areas. So now to think about the social consequences here. I've already commented that generativity is changing the nature of knowledge construction, and I'll talk about that more in just a moment. Latency complicates the whole issue of bias because the LLM constructs its interior data points synthetically, that is, through its own permutational process. And then something I'll talk about much more tomorrow night, how sequence and tokenization change the very nature of language in ways that are profoundly different from our usual linguistic analysis. And then finally, how fine-tuning through small data sets and prompt engineering result in zero-shot learning, that is something the LLM has never considered before, but now can learn very quickly through a few examples. So now let me talk a little bit more about generativity. So if we think about knowledge construction as a whole, we can identify what I call the space of possibilities. And within the space of possibilities, there are 2 different kinds of knowledge. One kind of knowledge is explicit. Those are things that we know we know. What is the diameter of the earth? What is the speed of light? Those are examples of explicit knowledge. But in addition to explicit knowledge, there are possibilities for implicit knowledge. Implicit knowledge comes about when data points are connected that have never been connected before. For example, what is the cause of rare diseases? Very difficult to determine that because by definition they happen rarely at at disparate locations. Well, an LLM now can connect those instances in ways that are very difficult for humans, and they've begun to discover all kinds of new knowledge which is there implicitly, but which they can now make explicit. For example, with protein folding, a formidably complex problem because of the stereochemistry involved. Very difficult for humans to do this, even with advanced computational techniques, but LLMs are able to do it, and on the basis of that have developed new drugs, and they've created all kinds of new knowledges. So how important is this implicit knowledge compared to explicit knowledge? Well, people who specialize in knowledge construction make a rough estimate that within the space of possibilities, only about 40% of the knowledge there is explicit. That means 60% is implicit, knowledge which is potentially there, but which needs to be made explicit to be useful. That is an enormous possibility for LLM creativity and contribution to human knowledge. But there are also limits on that. So I've talked about the space of possibility, but in addition to that, for humans, there's something that we could call the space of potentiality. And in contrast to the space of possibility, the space of potentiality is characterized by thinking entirely new ways to construct problems. Examples might be Einstein's theory of relativity, the invention of non-Euclidean geometry, and so forth. At present, only humans can access the space of potentiality. I do not think that LLMs are capable of this kinds of human creative insight, but in the future, I don't rule out the possibility they could also work within the space of potentiality. So as I've commented, LLMs and AIs are rapidly penetrating all other cognitive systems because they are a cognitive technology. They amplify the risks through non-human alignment. Perhaps they have values very different than human values. And they also are bringing about subtle changes in knowledge construction. So there is a risk of automated decision-making, algorithmic decision-making, and AI decision-making across economic, social, penal, and financial systems, among others. These will change how those systems operate in ways that we cannot now completely understand the implications of. So I would venture to say that my tiny selection here of ChatGPT texts show multiple kinds of cognition and intelligence, and they raise the question, what is the most productive use of AI intelligence? I think it's clear that the most productive use is to augment human intelligence, even to augment human literary theory and criticism. Now, there is another possibility that I will develop at length tomorrow, and that is LLM creativity may begin to allow us to develop a new kind of aesthetic, fundamentally different than a human-based aesthetic that has vast implications for literary theory and the interpretation of literary texts. So I said that AIs are opening a new chapter in human evolution, but the basic idea here is not new. It's been operating since the very beginning of the human species, and that is that humans co-evolve in evolutionary trajectories with our technology. For example, the domestication of fire changed human diets, and they changed the function of the jaw and the tongue in ways that facilitated the origin of speech. Bipedalism facilitated the fabrication and transport of tools, which conveyed such a strong adaptive advantage that in turn accelerated bipedalism. So now we've developed AI which can be regarded as a means to evolve life by means other than life. So here I will close with a prediction. Short of environmental collapse, and I mean that caveat seriously, we may render ourselves extinct. But if we don't, the trajectory of human and AI evolution will from henceforth be entwined. Thank you for your attention.